Right now, 800 light-years away, a planet called WASP b is still spiraling into the star that is devouring it, and astronomers at NASA and Caltech have no way to stop it. The planet is bleeding into space, right now, as you watch this. And what's happening to it is going to happen to worlds all across our galaxy, including one day maybe our own. But here's what nobody is telling you. The way this planet is dying isn't just slow. It's happening in a shape scientists never expected. And the reason why is the part they're afraid to say out loud. WASP-12b was discovered in 2008. A hot Jupiter, a gas giant crammed so close to its star that a year there lasts about one Earth day. 26 hours, that's it. It orbits at a distance where our own planet would be sitting inside the sun. Its star, WASP-12, is a yellow dwarf like ours, sitting quietly 600 light-years away in the constellation Auriga. Ordinary. Unremarkable. Until you look at what's orbiting it. The planet doesn't look like a planet anymore. It looks like a teardrop, stretched, torn, because the star's gravity is so brutal at this range that it has pulled WASP b out of its own shape and started peeling it apart, layer by layer, into a stream of gas trailing behind it like smoke off a dying ember. Then in 2017, Hubble caught something scientists did not expect. They pointed the telescope at WASP b to measure how fast it was losing mass and found a haze of heavy metals, gas so hot it glowed, forming a ring. Not around the planet, around the star itself. The planet's atmosphere isn't just leaking into empty space. It's falling onto WASP-12, feeding it, forming a thin accretion disk, the same kind of structure you'd expect around a black hole. Except this isn't a black hole. This is an ordinary star, quietly consuming a world whole. Every 17 seconds, that's how long researchers calculated it takes the planet to lose another 6 billion tons of its own atmosphere. 6 billion tons. Gone. Forever. Every 17 seconds while you read this sentence. And at that rate, the math is simple. Brutal. WASP b has at most 3 million years left. Here's where it stops making sense. Planets this close to their stars are supposed to lose mass evenly, a slow bleed pushed away by starlight and stellar wind. That's the textbook model. That's what astronomers at Harvard expected to see. But WASP b isn't losing mass evenly. It's losing it in bursts, sometimes brighter, sometimes almost invisible, in ways that don't match any existing model of atmospheric escape. Something is disrupting the flow. Something is warping the disk into shapes it shouldn't hold. And nobody, not at NASA, not at Caltech, not at any observatory watching this system, can fully explain why the disk keeps flickering the way it does. Here's the part they don't say loud enough. In 2019, a team modeling the light curve of WASP-12 found the star's brightness dimming slightly but consistently every time the planet passed in front of it. That's normal, expected. But the dimming didn't match a sphere. It matched a teardrop. An elongated, asymmetric shape, stretched by tidal forces until the planet's own gravity can no longer hold it together. WASP-12b isn't just losing atmosphere. It is being deformed at the level of its entire structure, its shape distorted by the same force tearing it apart. Picture that for a second. A world roughly the size of Jupiter, no longer round, stretched into an elongated shape by the pull of the star it orbits, its outer layers streaming away into a spiral that feeds directly back into the star's own surface. The star isn't just heating the planet to death. It is redrawing its geometry before it swallows it. And the strange part, the part that shouldn't be possible at all, the planet's interior still appears to be releasing enormous amounts of internal heat. More than any model predicts a planet this old should have left. As if something inside WASP b is fighting back against its own destruction, generating heat researchers can't yet trace to a source. This matters more than one dying planet 600 light-years away. WASP b is showing astronomers in real time the last stage of a fate that may be common across the galaxy. Every hot Jupiter crammed close to its star is on some version of this clock, just further back in time, just harder to catch in the act. And it forces a harder question about our own solar system's future. In about 5 billion years, our sun will swell into a red giant, and the inner planets, possibly including Earth, could face something like this. a slow gravitational unraveling, a shape pulled apart before it's finally consumed. WASP-B isn't a warning about aliens or asteroids. It's a warning about time and gravity and the fact that every star, even a calm yellow one like ours, is a slow-motion predator waiting for its orbit to bring dinner close enough. So the disk keeps flickering, the shape keeps stretching, the heat keeps leaking from somewhere nobody can identify. And in 3 million years, give or take, WASP-12b will be gone completely, swallowed whole. The only question left is what it's still trying to tell us on the way down. What do you think is happening inside it? Let us know below.